Good morning. So today we're going to be breaking up the video parts, the lecture part, if you will, of our lesson into two distinct parts. The first one, I will be going over review things, the stuff that we've already covered, and just making sure that we have a good grasp on that and remember those things because they're important going forward and we need to be as familiar with them as possible. Then in the second part, we will be going on to talk about forms of energy, which is the next part in our section. So starting out with review, do know that you'll have assignments that come along with each part of this video. And they're not going to be any huge deal. In fact, some of them you might find kind of fun. There's another video that I'm going to put up demonstrating how I would like you to do one of the assignments, although I would like yours to be shorter than my video. Anyway, we'll get to that when we get to that. So let's start out in a place of review. So far, we have talked primarily about kinetic and potential energy. And we've discussed that the main difference in kinetic and potential energy is the word motion. Kinetic energy is energy that is moving. I decided to borrow one of my son's toys to give you a good example of kinetic energy. So I'm just going to slide this back. Please ignore the fact that you are in the Johnson House playroom. So anyway, we have this cool little device and we have race cars. And if we put the race cars on them, we will actually see at the top they have gravitational potential energy. And then when I let them go, we see that gravitational potential energy turned into kinetic energy. So there's a quick review on two of the types of energy that we've discussed, gravitational potential and kinetic. So behind me, I have a board that I would like to remind you of. So remember, kinetic energy is what we look at when we look at motion. Kinetic energy is always going to be the energy of motion. When we saw those little cars moving, when they're at the top, they're just sitting there, they have potential energy. As soon as they start to move, it's kinetic energy. So again, this block, gravitational potential energy, as soon as I let it go, kinetic. Whenever it's moving, it's kinetic. And we calculate that by going for 1/2 mass times speed squared. Remember, squared does not mean multiplied by 2. 6 squared is not 12. 6 squared is 6 times 6, which is 36. So that is important to keep in mind. Speed and mass are the things that increase kinetic energy. I can drop this, and it's a pretty lightweight block, no big deal. If I grab something like a 5-pound cinder block and pick it up and drop it, it's going to be a much bigger deal. It has more potential to do work. So gravitational potential energy, what do we ask ourselves? Can it fall down? Yep. So whenever we're looking at gravitational potential energy, we are going to be considering the weight and the height of the object in question. Weight and height are going to be the things that increase gravitational potential energy. And to calculate it, we simply multiply weight times height. Pretty straightforward. Chemical potential energy. This is the one that I think we enjoy talking about the most. We ask ourselves the simple question: can I eat it or can I set it on fire? So that could be something as innocuous as a candle, right? A candle is full of wax. And a lighter, in fact, is full of butane. And when ignited, it will convert that chemical energy into a flame. I can light a candle, have it going, and I will talk about in a little bit how this is also giving us radiant energy and thermal energy. So I'm going to leave this candle going. A, it smells nice. B, science. So we can see chemical potential energy being converted into kinetic energy. And we know that this happens in our bodies with food. We toasted a marshmallow. This one's chocolate covered. I really hate the idea of setting it on fire, but absolutely I could eat it. So I'm not going to set that on fire. Instead, I have a mixture here of sugar and oil. Sugar and oil that's sugar and fats. That's things that make up very high calorie components of food. Can I eat them? Yes. Can I also set them on fire? Yes. And as you see, I have just kind of a burning lump of sugar and oil going on here. So I know that if I'm looking at food and at fuels, that's where I'm going to see my chemical potential energy going. Fuels like propellants that we might find in sprays. So chemical potential energy, pretty straightforward. Can I eat it? Can I burn it? Oh, third one, elastic potential. Is it stretched? Is it smushed? My necklace is made of elastic. If I stretch it, it's going to build up a lot of tension. It's going to build up a lot of elastic potential energy. And when I let it go, it does a fair amount of work on my face. I underestimated how big this marshmallow was going to be. And similarly, with the block, if I squish it down, it's been compressed. It has been smushed, if you will. And there's tension. As long as I'm holding here, it has elastic potential energy. When I let go, it bounces back. So we've seen lengthier demonstrations on those before. And I feel confident in our ability to discuss those. So moving on, here's where we start part 2 of the video. And we want to talk about different forms of energy. So first thing I'm going to do is switch us over to presentation mode, which means everything on the board will be backward. Finish chewing my marshmallow. All right. And now that I am in presentation mode, I'm going to go out of full screen so I can see this. Let's see. Oh, no. How do I get out of full screen? There we go. First thing I would do is go and pull up my class notes, as you should do anytime we are meeting. So all the stuff that I just talked about, we have in our class notes. Going on, and we'll just start on a new page. We'll get some bold, larger text going, so we know we're talking about something important. Forms of energy. And next to each one of these forms that we discuss, I will either put K or P. That will stand for kinetic or potential. So the first one that I want us to talk about is radiant or electromagnetic energy. So we're going to have electrical energy, which is one thing, and electromagnetic energy or radiant energy, which is another thing. You will see these terms used interchangeably, meaning that either one is acceptable. And radiant or electromagnetic energy is going to be energy that moves in rays or waves through space. So it's that last part, through space, that is very important to understand. We know, for example, that sound waves move in waves. However, sound has to move through matter. That's one of the types of energy we'll talk about. Sound has to move through matter. There's a phrase, in space, no one can hear you scream. That's because there's no matter. So when there's no matter, sound can't travel through it. It's not the same thing. Electromagnetic energy or radiant energy is going to be able to travel through space. This is going to include things like radio signals. When a radio station is sending out radio signals, they travel and move that energy through empty space and then are picked up and turned into sound energy by another machine. It includes things like lights. I have rays of light moving at me from the lamp. If I go back to my candle, I can see that there are rays of light going toward my hand. So light, X-rays, microwaves, which are not just an appliance, it's the actual wave that is used there. gamma rays, beta rays, anything that's going to be a ray or a wave that can move through empty space, we're going to go and know that that is electromagnetic. So I will add those examples in. So the question comes up, is this kinetic or potential? Well, the fact that we have the word moves, and I will underline it as well, tells us that this is going to be kinetic. So some examples, like we said, we'll put some in. X-rays. Hopefully no one is going to have any of those soon. X-rays, gamma rays, light energy, which would also include solar energy, of course. The light that comes off of your screen, all of those sorts of things will fall under this category. Okay, next one that I want to go over is electrical energy. Electrical energy is also going to be kinetic. And this is energy that comes from the movement of electrons. In fact, the movement of electrons is what electrical energy is. So examples of sources where we could find things like that, that's pretty easy to come up with. Anytime we're thinking about electricity, we know that our phones are going to use this. We know that computers do. The lights in your house, the air conditioning that you have. I'm thinking about that because mine is running pretty hard. Any electronic device. So anything that you have to plug it in, that's going to wind up having electrical energy. Electrical energy also extends. We find it in nature. We find it in talking about lightning. So, what is an electron? If we look at the structure of an atom, and this is a very poorly drawn atom, I'm just using it as an example. They're the negatively charged particles of atoms that hover around the outside in what we call valence shells. So from these valence shells, they can move from one atom to the next, to the next, to the next, kind of leave a hole, and another one will fill it in. And this is what produces electricity. When those electrons move, they're trying to neutralize the charge. Something will be positively charged, something else will be negatively charged. And as they move toward it, that's how we get electrical energy. The third one that we want to go over, which is pretty straightforward, is thermal energy. Oh no, I forgot to put it in bold. Thermal energy, if you think of what that word means, it's also going to be kinetic. Thermal energy has to do with heat. What we really say is energy that comes from collective molecular motion. That sounds very confusing. So we can also remember it as has to do with heat. So we want to make sure that we distinguish here, and I will talk about this more when we get into our unit about heat, that heat and temperature are not the same thing. Heat is the overall movement of molecules within a substance or an item. Heat is how fast those molecules are moving. So when we think about this candle, the overall movement of all the molecules in the glass, in the wick, in the wax, all of that together would be the candle's heat. Its temperature and the thermal energy coming off of it, I can feel the closer I get to the fire. That's going to be a little bit different. But if it has to do with heat and heat moving through things, because it does have to do with molecular movement, it makes it kinetic. All right, so again, we see the word motion. That tips us off to kinetic. We see movement of electrons. It tips us off to kinetic. All right, let's see. We have covered those: electrical, thermal, radiance, and electromagnetic. Nuclear energy. Let's talk about that. Nuclear energy, I would say, is potential energy. It's not entirely unlike chemical energy. So this is going to be energy stored in the bonds of particles, or let's actually specify those particles, of protons and neutrons in an atom's nucleus. So just like last year, when you talked about cells and cells having a nucleus, we know that the nucleus is the center of the cell. The nucleus is the part of the cell that, it's kind of the brain or the center of the cell. Atoms also have a nucleus. They have a dense part in the center. The electrons are moving around all willy-nilly. In the center of an atom are two types of particles, protons and neutrons. Protons carry a positive charge, neutrons have no charge. And they are extremely tightly bound. It's the strongest force on Earth is the bond between these little particles inside of atoms. So when we talk about nuclear energy, we're talking about what is stored in those bonds. When we release nuclear energy, we know what happens. When these are split and those bonds are split, or when they are fused together. We have nuclear fission, which is splitting apart, and nuclear fusion, which is bringing atoms together, both very difficult to do. Enormous amounts of kinetic energy, mostly in the form of radiant and thermal, as well as sound energy, is released. And it's absolutely extraordinary. You know, when we first think of nuclear energy, what we often think of is nuclear weaponry. And that's not the only use for it. We use nuclear energy to create electrical energy and provide us with electricity to fuel our lives. And it can be a really good thing. We will talk quite a bit more about it, partly because it's on the standards and partly because I find it really interesting and my whole family works in the nuclear energy sector. So we'll learn a lot about nuclear energy. But it's important to know that while we're talking about it when it is stored and they are stuck together. It takes a lot of effort for humans to split atoms or to fuse them together. It happens naturally in some places like stars, but outside of that, it's an extremely difficult process. So I do want to add in that we have fission, where we split an atom, or at least we split the nucleus. I keep spelling nucleus wrong. And we have fusion, where we combine two nuclei. That is the plural for nucleus. All right, and the last one I want to cover is mechanical energy, and it is one that we can calculate. So mechanical energy is interesting because it is a combination of both kinetic plus potential energy. Okay, so this sounds weird. You're like, how can something be both kinetic and potential energy? Well, mechanical is exactly that. It is the sum of an object's kinetic energy and potential energy. For example, when a ball travels through the air, it loses kinetic energy as it rises and gains kinetic energy as it falls. As it rises, it gains, not kinetic, potential energy. And loses it as it falls. So this tells us that there is an inverse relationship between kinetic and potential energy when it comes to the actions of something. So to demonstrate, I'm going to move my high chair board. Please, again, excuse my mess. Let's take a look at a ball. All right, so when I throw a ball, right, what happens? The ball will go up and then go down, right? Pay attention as it goes up, and you will see that there is a point when the ball actually kind of stops. As it goes up, it will slow because of the force of gravity. And as it's slowing down, it's losing kinetic energy. We see its speed decrease, which means that its kinetic energy is decreasing. But its height is going up, which means its gravitational potential energy is rising. As it starts to fall, its speed will increase, meaning its kinetic energy will increase. However, its height will decrease, meaning its potential energy will also decrease. Okay, ready? That's a lot to take in from this. Okay, I threw it a little too far, so I'm going to throw it just straight up this time. So watch, and it will slow to the top. Gets slower, falls down faster. Gets slower, falls down faster. So if we combine at any given point the number of joules that this ball has as it's traveling, we should get the same number wherever it is. So if right here, just sitting on the ground, it has 10 joules of energy. When I throw it into the air, it may be the case that right here, it has 5 joules of potential energy and 5 joules of kinetic. When it hits the point that it stops, it has 10 joules of potential energy and no kinetic energy. As it falls, we might go back to that 5 and 5, and right before it hits the ground, it might be 9 joules of potential energy, or of kinetic energy, and 1 joule of potential energy. When it hits the ground, it's all back to potential energy. So mechanical energy, we can calculate it for anything. All we have to do is look at the combination of those two types of energy. All right, so that's kind of the basics on our forms of energy. I do have a video that I want to show you that goes along with this. Sorry, I know this has been a little lengthy, but I want to make sure that I'm really hitting all my corners here and making sure that everything is laid out as best I can. We have added to our class notes, thinking about a ball. We've gotten these forms of energy down. If we look back to our standard, analyze the properties and compare sources of kinetic and potential energy, mechanical, gravitational, elastic, electric, chemical, radiant, nuclear, and thermal energy. Well, we've done that, guys. We have found sources. If we look at our learning objectives, we should be able to go through and figure out all of these things. A transformation, that's, when we light something on fire, it transforms from potential to kinetic energy. Fire is radiant energy. And also produces thermal energy. Another energy transformation, when we split an atom, it transfers into a lot of different types of energy, or transforms. Energy transfers, that's when we see kinetic energy bumping back and forth, just like those poor speed skaters. All right, so let's see if I can find my favorite video for this. Maybe I can, maybe I can't. Come on, YouTube, you can do it. You can take your sweet time, but you can still do it. Okay. Types of energy. Oh dear, I can't find the one that I like. I hope it hasn't been taken down. Let's try forms of energy. Eesh. Okay, maybe I spoke too soon. I think this is a different, you know what? I can't find the video I want. That's a real bummer. So we will take a quick look at some of the different types of energies, sources, and uses. This video is going to basically just go over everything that I just did. The law of conservation of energy is going to have to do with that mechanical energy principle that something always has energy. We'll learn that it can't be created or destroyed.
More than 20 million people use Grammarly every day to improve their writing.
Skip.
Hello, friends. Today, we'll learn about energy. Energy is the ability to do work. It takes energy to play, to stand up. There are many types of energy, which all fall into two primary types. The energy of moving objects, called the kinetic energy, and the energy that is stored, called the potential energy. Let's see the different types of energy one by one. Gravitational energy. It is associated with gravity or gravitational force. It is the energy held by an object because of its high position compared to a lower position. For example, see these elephants? This one has more gravitational potential energy as it is on higher ground, and this one has less, whereas gravitational force acting on both is the same. Thermal or heat energy. It is created from the vibration of molecules and atoms within substances. The faster they move, the more energy they produce, and the hotter they become. Chemical energy. It is the potential of a chemical substance that undergoes a transformation through a chemical reaction to transform other chemical substances. For example, the food we eat is digested to convert chemical energy into other forms of energy used by cells. Electrical energy. It is generated by moving electric charges called electrons. Lighting and electric cells are examples of electrical energy. Radiant or light energy. It is a form of electromagnetic radiation. Light travels in waves and is the only kind of energy humans can see. For example, the energy from the sun. Nuclear energy. It is the energy that holds together the nucleus of atoms. It is released during nuclear fusion. Elastic energy. See this toy with spring? Elastic objects like an elastic band or coiled spring stores elastic energy when a force causes them to be squashed or stretched. Mechanical or motion energy. It is the energy associated with the position and motion of an object. Sound energy. It is produced when sound waves move outward from a sound source or a vibrating object. The standard unit of measure for energy is the joule, which is abbreviated as J. Oh yes, it's time to learn the law of conservation of energy. It states that energy can never be created nor destroyed, but it can be transformed from one type to another. Conservationists classify the energy into two types, renewable and non-renewable. Non-renewable are those energy sources which cannot renew itself or takes millions of years for its formation. These include nuclear fuels, petroleum, natural gas, coal, etc. Renewable energy is those energy sources which can be renewed easily by physical, chemical, or biological process. Examples are wind power from windmills and solar power from the sun. We should save energy as much as possible. Saving energy can reduce greenhouse gas emissions and contribute to a healthier planet. Now, you know a lot about energy. Stay tuned. Bye-bye.
Good grammar and spelling are important. But if you want to write essays that inspire, messages that forge...
Okay, I've been joined by a little bit of an energy draining pest. This is Ogle. Anyway, so that video hits on a couple of things that I do want to mention. when he talks about mechanical energy, he mentions that it's from both the position and the motion of an object. And if we think about the combination of kinetic energy and potential energy, that's exactly what we would be thinking about. We know potential energy comes from something's position or what it's made of, and kinetic energy comes from motion. So the way he says that is perfect. The law of conservation of energy is what we will be talking about tomorrow, maybe the next day. I'm not sure. It just depends on how things go. Stating that energy can never be created nor destroyed, that is absolutely correct. There is a finite amount of energy in the universe. It just transforms into different types of energy as we go along and do things, or as things go along and happen throughout the universe. And then sound energy, I did not add in, but I'm going to add that into our notes very quickly. So we're going down. And sound energy is going to be also kinetic. Sorry, without my glasses, it's hard for me to see the screen, but with my glasses, there's just a terrible reflection. So sound energy moves in waves and results from the vibration of objects. So, basically, like, think about plucking a guitar string. As you, see that guitar string vibrate, you hear sound energy. Your vocal cords, as I'm speaking right now, mine are kind of wearing out. But vocal cords are a great example of something that they vibrate. And as they vibrate, they produce sound, and that is how we are able to speak. So I'll stop there and conclude on my forms of energy. I am going to post a video and an assignment that goes along with this lesson. It should be a fun one. The other video is about 15 minutes long, so you have to watch me for another 15 minutes. But it just is there to kind of demonstrate to you how much these forms of energy are just present in your everyday life. Like, without even thinking about it, you go through just tons and tons and tons of energy transformations and these different forms of energy in just everyday things. I'm holding this source of chemical energy right here. I could eat him and he would be just full of fat and calories, I'm sure. I have some here. I'm using electromagnetic energy to make this video and communicate with you. My vocal cords are resonating sound energy. I'm using basic kinetic because I'm Italian and just talk with my hands all the time. So you watch this other video, do the other assignment that goes with it when it comes up, and we should have a pretty good time. All right. Take care, and I will talk to you guys soon. Bye.